Okay, so obviously what we're doing is we are doing area. And area is something that we have done many times. It's not like a new thing for y'all. Y'all do it in a lot of different grades. But now we are going to be putting in that special right triangle piece and like different ways that they don't just give you the information. You're going to have to figure out the information. So I'm going to give you the formulas. Y'all are going to have these to be able to use on the board work today. And then, then you'll do some practice problems together. So let's start with parallelogram. So like right here, this is a parallelogram. Can anybody tell me the area formula for a parallelogram? Okay, length times width. I will say that works best for rectangle and square, which is a parallelogram, but there's a better one.
Base times height.
Base times height. So area equals base times height. Now, one thing we need to make very clear, and this is going to be used for most shapes, height, and I'll say this right now, and even today in all my other classes, I'll say, do not use this side, and they still use it. The height is not the slanted side, okay? If you are trying to find the height of like a rectangle, you're going to go from top to bottom, right? You're not going to go from at a diagonal. That's not going to be the height of your rectangle. So whenever we have the height, what we do is we find what we call a perpendicular height. That means that it is perpendicular to the base. So right there, that would be your perpendicular height, okay? It has to have a 90-degree angle for it to be a height. And you're going to see that in every single shape that we pretty much talk about. But it's always going to be going the opposite direction of your base. Another thing I needed y'all to get used to, this is not just for this unit, for other units, please get used to base does not always mean the bottom, okay? The base can actually be any side of your shape. What's just going to happen is like it's going to like, it might shift it. So let me just give you an example. If I were to give you a parallelogram that looked kind of the same as this. Whoop. Let me go slow this one. If I gave you a parallelogram that looks something like this. Okay. But instead of the bottom being the base. Move that out just a little bit more. Instead of the bottom being the base, let's say that this side was the base right here. Well, how is that going to change my height? Right, the height's going to go horizontal. Now, this is kind of hard for me to draw, so just like bear with me. It still has to be perpendicular. So it's going to look something like that. Hold on, sorry. It's going to look something like that. It's really hard to draw. I have been trying to draw this like on all my periods, but
It's okay.
thank you. So something like that. Yeah, it's gonna be like there. Oh, just moved it. Okay, so that's going to be your height right there. But it's going to be going the opposite direction. And again, you have a 90-degree angle that way. So height does not always mean, base does not always mean bottom, but your height and your base are always going to be going different directions. When you have a rectangle or a square, your height and base are just like built in. So when you have, when you have this right here, you have a rectangle, your base and height are just going to be the sides because we don't have that that slant that you have with a normal parallelogram, okay? Same thing with a square because your sides are all, or your angles are all 90 degrees. You're still going to have that natural base and height. Okay, so now let's go to a triangle. What is the equation for a triangle? Okay, so this is going to be area equals base times height divided by 2. Now, we have talked about this multiple times. What is another word for height in a triangle?
Height.
No, another word for height.
Oh. The altitude.
The altitude, okay? So we've looked at altitudes a lot. We've found altitudes a lot. So right here, what we've talked about more this year is that this line would be considered an altitude. The vertex to the opposite side, again, with a perpendicular angle, or a 90-degree angle because it's perpendicular. And then this would be your base. And then also with triangles, again, it can be any side. So if I have like the same kind of like, well, any type of triangle, if I have this triangle right here, bring this out a little bit more. Okay, if I have that triangle right there, this would still be like, we could go, okay, well now this side over here is the base. And if that side right there is the base, what's going to happen to my height? Right. Now, sometimes your base is going to be outside, or sorry, your height can be like outside of your triangle, because in order to get that 90-degree angle, it has to be on the outside. So it might look something like this. And you have a 90-degree angle right there, but yet we still have that this is the height and this is the base. So again, it's just like going the opposite direction, all that stuff. Now, with right triangles, that's kind of like your square and rectangle, where if you have a right triangle, it's built in to the side. So if I have a triangle, a side right there, a side right here, any side that makes the 90-degree angle is going to be your base and your height. So right here, sorry, hold on. Base. Thank you. Then that's your height, because your legs are going to be your base and your height. Okay, do you have questions on that? Okay. Any other questions or any questions? Okay, so now we're going to look at a trapezoid. Does anybody know trapezoid?
It's a triangle with a rectangle in it.
Right, but what's the area equation for trapezoid?
Oh, base, the difference in base divided by 2.
Okay, so this is going to be, the way that we write this is we're going to do base 1 plus base 2. Okay, so we're finding the sum of the two bases. And we're going to multiply that by the height and divide by 2. Now again, with your standard trapezoids, your sides are slanted, and that's not where you're going to get your height. You're going to get your height from the inside piece right here, and it's the distance between your base 1 and base 2. We're trying to figure out how far apart those are. And again, we have this like 90-degree angle right there. Let me use a different color because I think this will show up better on the, there you go. And then here's your base 2, base 1. Now, one thing that is very simple about trapezoids is that base 1 and base 2, just a little statement right there. That right there is an and sign. That's not a plus sign, so it's not base 1 plus base 2. When I do that, I'm talking about base 1 and base 2. These right here are always the parallel sides. So trapezoids only have one set of parallel sides. Okay? So bases can't be any side on a trapezoid. It has to be base 1, base 2. Okay? So are we good on that? Height. Oh, that was the other thing. I need to give you an example of a trapezoid. So sometimes you can have a trapezoid that looks like this. And if this is your trapezoid right here, then again, you have this 90-degree angle right here. So this would be your height because the 90-degree angle is built into your side. And then this would be your base 1. This would be your base 2. Maybe. So just keep that in mind whenever you have like a 90-degree angle made with one of your sides. Okay. Next one, we're going to be talking about kite or rhombus. A rhombus is a rhombus is a parallelogram, but we can use this with, we can use the kite formula for rhombus also. And what you're going to notice is the reason why we can use that is because our diagonals are parallel. And one thing that we've been looking at is not parallel. The diagonals are perpendicular. So when this diagonal 1 right here intersects with this diagonal 2 right here, they make a 90-degree angle in the middle. So we still have that 90-degree angle or that perpendicular relationship. Same thing right here with this kite. When we go up and down for diagonal 2 and then go across for diagonal 1, then we have a 90-degree angle and we have that perpendicular part for that relationship. So then we have that the area equals, please write this down correctly because I'm going to write something else in just a second and everyone gets these parts mixed up. This is diagonal 1 times diagonal 2, all divided by 2. In the formula, you are multiplying the diagonals. Now, this is why people mess this up. Because I put over here, I put diagonal 1 and diagonal 2. That is not doing diagonal 1 plus diagonal 2. That I'm saying diagonal 1 and diagonal 2. That represents, or D1, D2 represents diagonals. Well, when I write this piece down, everybody wants to, like not everybody, but people want to change the formula to diagonal 1 plus diagonal 2. We're multiplying them, okay? Any questions on that? Okay, the last thing we need to talk about is circles. So our formula for circles, if we have just like a single, we want the full circle. We're going to do area equals pi r squared. Okay? If I wanted to find a semicircle, the area of a semicircle, what would I do? Yep, pi r squared over 2. So you just take it, you divide that by half. That is giving you the area, meaning the inside of the full circle. If I was going around the circle, what would I find? Circumference. So we have circumference, we have area, but instead of doing 2 times pi, we're taking the radius and squaring it. It's different. Okay, so then we got to do sector of a circle. A sector of the circle is not the whole circle. It's just a piece of the circle. Okay, so a sector of a circle is very similar to that arc length that we did last time, because instead of finding a piece of the arc or a piece of the circumference, we're finding a piece of the whole area. So the way that we're going to write this is we say area equals, and we're going to do theta over 360, because we're going to figure out what proportion or what percentage of that is. And then we multiply that by the area equation, pi r squared. What does theta stand for?
Angle.
Angle degree, right? The degree of your central angle. Okay, so like I said, a lot of this you already know. But now what we're going to do is we're going to not just, some of them, yes, you're just going to have the information and we're going to practice plugging in the equation and solving. The rest of them, some of it's going to be like you're going to have to find the missing information. Mostly today with like the board work, it's going to be practicing that special right triangle stuff. Sometimes you're going to have to use Pythagorean theorem. Sometimes you're going to use special right triangles. There's going to be a lot of options. So that